All right, this section is going to be dealing with your natural exponential function. So like last time we dealt with our natural log. So you have a little bit of relationship between your natural exponential and your natural log. So f of x equal e to the x is considered to be your natural exponential function. And as it states, the inverse function of your natural exponential is the natural logarithm. So they are considered to be inverses of each other. Now, because of that, you can actually interchange between the two forms. And that's what you see that I have here. So like this first one where I have y equal e to the x, this could be rewritten as x equal natural log of y, okay? So basically what you do, and it's just a matter of memorizing what has to go in what location. If this is the natural exponential, you have to use natural log, you have to use ln. But whatever your exponent is, that's what this natural log is going to be set equal to. Okay, so you have to say equal to the exponent. And then what you use as your argument here for your natural log is going to be what the exponential was equal to. So you just need to, like I said, memorize actually where does the y go, where does the x go. So like this example that I have here, if I were to change this over, like you could go ahead and put your equal and put your ln. So see, my exponent's a -2, so that's what the ln will have to be equal to, and the 0.135 is what would be used as the argument for that natural log. Now what we're going to do first is just solve some equations, and you've done this before, even as early as Algebra 2. And at the top I have a couple of properties, and if this is ln, remember your subscript that you have here is an understood e, and anytime that these two things are the same, then it's just going to be equal to whatever the exponent is. That's actually a property we had looked at earlier. And then on this one, if you have e to a natural log, then whatever you have here as your argument is what this will be equal to. So just a couple of properties that we're going to end up using along the way. All right, so the first two problems that you see here are exponentials, natural exponential equations that we're going to solve. You do need to make sure that your exponential's on one side by itself, like this one's already by itself. When I go to work number 2 in a minute, then I'll need to get this e to the 4x by itself. All right, once you have your exponential by itself, then you're going to take the natural log of both sides. So you'll have the natural log of e to the 2x minus 1 is equal to the natural log of 8. Now you're going to use the property here that I was just explaining here. Since these are both e's, which is exactly what I have here, these are both e's, then this whole left side is just equivalent to whatever you have as your exponent. So for this problem, that would just be 2x minus 1. Okay, so now at this point, you need to solve this equation. So we're going to add the 1. We'll have 2x is equal to the natural log of 8 plus 1. Now you cannot add the 1 to the 8. Natural log of 8 is not going to change. Then you've got to divide by 2. So we got the natural log of 8 plus 1 divided by 2. Now that would be considered your exact answer. Of course, you could enter this into your calculator to get your approximation, which the approximation is going to be, and I'll keep, say, about 3 decimal places. So you'd have to round up to 1.540 if you're going to keep 3 decimal places. Okay, on the next one, as I had said, you've got to have your exponential by itself. So this is my exponential. I need it by itself. So I've got to start by adding the 1. So I'd have 2e to the 4x is equal to 12. Then you got to divide both sides by 2. So you have e to the 4x is equal to 6. So now you're at a point to where we were with the first example. So now you're ready to take the natural log of each side. Okay, again, since your subscript here is an understood e, then this side is just equivalent to the exponent. And now to get x by itself, you divide by 4. Now you cannot reduce the 6 and the 4, okay? Whatever number you have after the ln, you can't ever do anything with it, okay? It's locked in as being a 6. So natural log of 6 divided by 4. And if I keep 3 decimal places here, then that's going to be approximately 0.448 would be my approximation. Okay, now let's look at some natural log equations. Okay, so you need to have your natural log on one side by itself, which I do here, but you got to keep in mind there's an understood e. So if I were to change this from log form to exponential form, okay, that means that I would have e to the 7th power is equal to x plus 1, okay, and it's just a matter, again, you've got to memorize where things have to go when you change it over. So it's always going to be the e to this power equals the argument, okay? So now all I've got to do to get x by itself would be to subtract the 1. So I'm going to have e to the 7th minus 1. So that would be your exact answer. Of course, if you put this in your calculator, so e to the 7th minus 1, then my approximation would be 1095.633. Okay. All right, the next one that I have, what I would need to do first would be to subtract the 6. I need to have my natural log by itself. So I'd have natural log of 2x is equal to 4. Okay, so remember there's an understood e here. So I'd have e to the 4th power is equal to 2x. So now to get x by itself, divide by 2. So that would be e to the 4th divided by 2. So that would be your exact answer. So then if you enter this into your calculator, so e to the 4th divided by 2. So this would be approximately 27.299.